Hi, I'm Miss Roger, and welcome back to Core Concepts in Algebra 2. Today's lesson is on trigonometric functions in the unit circle. The Massachusetts curriculum frameworks for mathematics are tied to this lesson, specifically FTF, trigonometric functions, number 1 and number 2. Today's lesson objectives are to understand radian measure, to convert between degrees and radians, to examine angles on the unit circle, and to use right triangle trigonometry in the reference circle to determine x and y coordinates on the unit circle. In trigonometry, we often measure angles with a new unit called the radian. We need to first define what a radian is and how we can convert between degrees and radians. So our formal definition: a central angle of a circle has a measure of 1 radian if it intercepts an arc with the same length as the radius. 1 radian is the measure of a central angle theta that intercepts an arc s equal in length to the radius r of the circle. So in our diagram here, this is our intercepted arc and this is our central angle. And our radius for the unit circle is 1. Therefore, our theta is going to equal our arc over our radius, where theta is measured in radians. Let's take a look at what our angles specifically look like. The standard position of an angle is when the vertex of the angle is at the origin and the initial ray is on the positive x-axis. A positive angle is rotated counterclockwise from standard position. The terminal ray must rest in any quadrant. When we have a negative angle, it's rotated clockwise from standard position, and the terminal ray again may rest in any quadrant. So if we look specifically, this is going to be one of our positive angles. This is our origin, and we're going to start and go in a counterclockwise direction. If we think about our negative angle, we're going to go in a clockwise direction. This is our initial side, and this is our terminal side. So when we think about an angle, we always start with the initial side and end at the terminal side. Let's take a look at some more definitions and facts. Angles may be rotated more than 180 degrees in the positive or the negative direction. Recall that all circles are similar, and the circumference of a circle is 2 pi r. Remember that circumference is a distance. A revolution of 360 degrees traces one circumference of a circle. Consider the unit circle with a radius of 1. So if we're thinking about 360 degrees and how this corresponds to radians, because we want to think about this in respect to radians, we can think about this idea of 360 degrees equaling the circumference of a circle, which is 2 pi r. In this problem, r is 1, and when we think about the unit circle, our radius is 1. So when we do that, we can think about this as 2 pi radians, because 360 degrees equals 2 pi times 1, which is just 2 pi. If I think about 180 degrees, this is going to be half of 360 degrees. So if I take my original idea and I divide this in half, whatever I do to one side, I must do to the other, I'm going to get 180 degrees equaling pi radians specifically. And for my last one, if I take 180 degrees and I divide this in half, this is going to equal pi over 2. So when I think about 360 degrees, I want to think about this as 2 pi radians. When I think about 180 degrees, I want to think about this as pi radians. And when I think about 90 degrees, I want to think about this as pi over 2 radians. Let's take a look at what this is going to look like on our unit circle. So 360 degrees, back to our last description, we're going to start with our initial side, and we're going to go around the unit circle until we get back, which is 2 pi radians. If I want to think about 180 degrees, I'm going to start with my initial side and stop here. This is going to be pi radians. Also, one thing to notice and to make a note of, I don't have to keep writing radians. For this chapter, if you don't see anything written, it's denoted as radians. It's considered radians. So when you are using degrees, you either want to write degrees or use the degree symbol. And our last one, pi over 2, we start with our initial side. Here's the center of our circle. And we're going to go to here. And this is pi over 2. Let's take a look at some more problems. We want to be able to convert between degrees and radians and feel comfortable doing both. The majority of this chapter, we're going to examine radians and be using radians. So we want to be very comfortable. So to go from degrees to radians, what we're going to do is we're going to take whatever our degree measure is and multiply it by pi radians all over 180 degrees, and this will give us our radians. And for converting from radians to degrees, we're going to take whatever our radians are and multiply it by 180 degrees all over pi radians, and this will give us a degree measure. Let's take a look at an example. So if I look at 30 degrees, I want to figure out what this is going to be in radians. So what I do is I multiply this by pi radians all over 180 degrees. And when I think about fractions, I always like to just put that over 1 so I can see kind of what's going on. So when I simplify this out, I'm going to get pi over 6 radians. Again, I don't need to write radians if I don't want to. Pi over 6 is good enough. Let's take a look at a problem where we go from radians to degrees. If I want to think about this same problem, I can go from pi over 6, which is my radians, and multiply this by 180 degrees all over pi radians. So my pi's cancel out, and I get 180 degrees all over 6, which will simplify to be 30 degrees. Recall right-angle trigonometry from geometry, SOHCAHTOA. This is an acronym we use in geometry to help us. The sign stands for opposite over hypotenuse. The COA stands for cosine, adjacent over hypotenuse. And the TOA stands for tangent, opposite over adjacent. These are our reciprocal functions. So when we think about our unit circle and we connect it back to our standard form equation of a circle where our center is h comma k, our center of our unit circle is going to be 0, 0, which is at the origin, and our radius is going to be 1. So if we think about what our equation is for our unit circle, we're going to have x squared plus y squared equals r squared, where r equals 1 and our center is 0, 0. This is for our unit circle. So if I think about what sine is, it's going to be our y over r, which is just y if our radius is 1. Our cosine is just going to equal x, again if our r is 1 for our unit circle. Our tangent is going to be y over x, where x can't equal 0, because then it would not be defined. Our cosecant, which again is our reciprocal function of sine, is going to equal 1 over y, since our radius is 1, and y can't equal 0. Our secant, which is the reciprocal function of cosine, is going to equal 1 over x, in which x can't equal 0. And our cotangent is going to equal x over y, where y can't equal 0. Let's take a look at how this connects to our triangle and the unit circle. Let's take a look more specifically. For any right triangle, if we were to locate theta at the origin of our Cartesian plane and let the hypotenuse be the radius of the circle whose center is also at the origin, then the adjacent side becomes the horizontal component and the opposite side becomes the vertical component. So what does that mean when we look at a triangle? Our hypotenuse is going to be r, our adjacent side is going to be x, and our opposite side is going to be y. This is going to be useful when we look at our trigonometric functions. So if we think about this as theta, our opposite side is going to be here. We have our hypotenuse here. And then we have our adjacent side to our theta here. So if we want to locate what we have going on here, our hypotenuse is r, we have our opposite side as y, and our adjacent side is x. We're going to use these when we're thinking about right triangle trig. The other thing you want to make a note of is our radius is always going to be positive. In our case, it's 1 for our unit circle, and in future sections, we'll be able to see when it's a different value. But for right now, please make sure you consider the radius is always positive. Let's take a look at special right triangles. Recall from geometry, our 30, 60, 90 triangle. Specifically, across from the 90-degree angle, we have a value of 2. Across from the 30-degree angle, we have a value of 1. And across from the 60-degree angle, we have a value of square root of 3. If you think about the previous topic that we just talked about, our hypotenuse is 2 here, which means our radius is 2. We want our radius to be 1 for our unit circle. So in order to do that, we need to make this value a 1. So if I think about how I can do that, I can divide each of these values by 2 in order to make this a 1. 2 divided by 2 is going to give me that 1. 1 divided by 2 is going to give me a half. And radical 3 divided by 2 is going to give me radical 3 over 2. And here we have in fact made r equal 1. This is specifically the triangle that we're going to use when we're thinking about trigonometry in our unit circle. Same goes for the 45, 45, 90. We have our isosceles triangle where the legs are 1 and the value of the hypotenuse is radical 2. Here, r equals radical 2. We want r to equal 1. So again, how can we make this triangle have a radius of 1? We want to make this value 1 so we can divide each of the sides by radical 2. Here, r equals 1. Radical 2 divided by radical 2 is 1. 1 divided by radical 2, we need to eliminate the radical from the denominator. So we're going to take 1 over radical 2 and multiply it by radical 2 over radical 2, which is going to give us radical 4 in the denominator, which is a perfect square to give us 2, and 1 times radical 2 in the numerator to give us radical 2 over 2. So this value here is going to give us radical 2 over 2, and since it's isosceles, this side is also radical 2 over 2. We're going to be thinking about our 45, 45, 90 and these values for our unit circle as well. Let's take a look at how our 45, 45, 90 triangle corresponds to our unit circle. Pi over 4 is going to be 45 degrees. So let's take a look at our picture. If this is 45 degrees, the special right triangles that we just looked at, we want to kind of think about this as one triangle. So we just talked about how the radius was 1, and we had radical 2 over 2 and radical 2 over 2 for these two lengths. So this is our first kind of look. When we think about what this ordered pair is, because now we're going to start to extend this to what this XY ordered pair is. Let's think about it. Our x is this value, so we have radical 2 over 2, and our y is this value, radical 2 over 2. So the ordered pair that corresponds to 45 degrees is radical 2 over 2, comma, radical 2 over 2. So this is one of our first ordered pairs. We can use this idea and how I've mapped this out to build other coordinates on our unit circle. So if we think about this same idea, if we think about this as also 45 degrees and kind of what's happening, and these two sides being congruent, our radius being 1, we're going over in the negative direction here, so we're going to have negative radical 2 over 2, and our other leg is going to be positive radical 2 over 2. I can think about what the coordinates of this point are going to be based off of my reference circle. So my x point is going to be negative radical 2 over 2, comma, and my y value is positive radical 2 over 2. Again, I can keep going around the circle and figure out what the coordinates of this point are going to be. My hypotenuse is always positive. It's a value of 1 on our unit circle. This value is going to be negative radical 2 over 2 because we're going down. And we already figured out that this is going to be negative radical 2 over 2. So when I think about my xy ordered pair, x is negative radical 2 over 2, and y is negative radical 2 over 2. Our last triangle that we're going to use is going to be this one. So our x we figured out is positive radical 2 over 2. Our hypotenuse and our radius is 1 since we're on the unit circle. And since we're going down in the negative direction, this is going to be negative radical 2 over 2. So our xy ordered pair is going to be radical 2 over 2, comma, negative radical 2 over 2. We can now use these coordinates to help us figure out the sine, cosine, and tangent of these values, specifically pi over 4. So recall, pi of theta is y over r. Cosine of theta is x over r, and tangent of theta is y over x. So when I think about my 45-degree triangle, I'm going to think about what my y-coordinate is. My y-coordinate is specifically radical 2 over 2. My r value is 1. Anything divided by 1 is just 1. So sine of pi over 4 is going to be radical 2 over 2. Let's look at cosine of theta. X over r. Again, r is 1. So our x value, or coordinate, is going to be radical 2 over 2. So cosine of pi over 4 is radical 2 over 2. Our last one is tangent of theta. We can use our above sine and cosine, or we can think about it as y over x. Our y, or our sine, is going to be radical 2 over 2. Our x value is also radical 2 over 2. So I could think about this as a multiplication problem and do radical 2 over 2 times the reciprocal of the denominator, or I could just think about this as being a value of 1. So tangent of pi over 4 is 1. Let's take a look at another problem using the 30, 60, 90 triangle. For pi over 6, which is 30 degrees, we're going to connect this to our unit circle. So if I think about this unit circle in which my central angle is 30 degrees, across from the 30-degree angle we had a half, across from the 60-degree angle we had radical 3 over 2, and across from the 90-degree angle we had 1. And again, remember, this is our radius of our unit circle. So again, if I want to figure out what this ordered pair that corresponds to 30 degrees, I use an x and y coordinate. X is radical 3 over 2, and our y is 1/2. I can keep going along and figure out more coordinates, so let's do that. My hypotenuse is 1. This value is going to be 1/2. This value is going to be negative radical 3 over 2. So if I think about this and what I have going on here as an xy ordered pair, I have my x as negative radical 3 over 2 and my y as 1/2. Using this same idea. For this problem, I'm going to have across from my right angle 1. I'm going to think about this as my 30-degree angle. So across from this is going to be negative 1/2 since I'm going down in the negative direction. And we already figured out that this value is going to be negative radical 3 over 2. So this coordinate as an xy ordered pair is going to be negative radical 3 over 2, comma, negative 1/2. My last ordered pair that I can find using my reference circle and 30 degrees is going to be this ordered pair, where my hypotenuse is 1. I can think about this as my 30-degree angle. Across from that is going to be negative 1/2, since I'm going down in the negative direction. And I already figured out that that's going to be radical 3 over 2. So as an xy ordered pair, this is radical 3 over 2, comma, negative 1/2. I can now connect this to trig, sine, cosine, and tangent of pi over 6. Recall that sine is y, cosine is x, and tangent is y over x. Our radius is 1, so I'm going to eliminate the fact that this is over r and over r. Our y value for pi over 6 is going to be 1/2. So sine of pi over 6, or 30 degrees, is 1/2. Cosine is our x value. This is going to be radical 3 over 2. So cosine of pi over 6 is going to be radical 3 over 2. Our last problem is going to be tangent. Tangent is going to be y, which is 1/2, all over x, which is radical 3 over 2. We need to manipulate this. We can't leave our final answer like this. So we're going to do a little bit of side work. I'm going to change this to be 1/2 times, make it a multiplication problem, the reciprocal of this, which is going to be 2 over radical 3. 2 times 1 is 2. Radical 3 times 2 is 2 radical 3. And again, I can't have radicals in the denominator, so I'm going to multiply this by radical 3 over radical 3. In the numerator, we have 2 radical 3, and in the denominator, we have 2 times radical 3 times radical 3. Radical 3 times radical 3 is radical 9, which simplifies to be 3. So 3 times 2 is 6. And now I can simplify my 2 and my 6. 2 goes into 2 once, 2 goes into 6 3 times. So my tangent of pi over 6 is going to be radical 3 over 3. Let's now look at pi over 3, which is 60 degrees. Again, we're going to build the coordinates on our unit circle and eventually make up all the coordinates on the unit circle using our 45, 45, 90 and our 30, 60, 90 triangles. So if we think about 60 degrees or pi over 3, we can connect this. Across from the 90-degree angle is 1, which is our radius. Across from our 60-degree angle is going to be radical 3 over 2. Across from our 30-degree angle is going to be 1/2. So if I think about my xy ordered pair, my x value is going to be 1/2, and my y value is going to be radical 3 over 2. Let's keep going. This coordinate, again, my radius is 1 across from the 90-degree angle. I'm going to think about this as my 60-degree angle. Across from that is radical 3 over 2. And this is going to be negative 1/2 if I'm going over in the negative direction. So this ordered pair is going to be negative 1/2, comma, radical 3 over 2. This coordinate in respect to x and y. My y value is going to be negative radical 3 over 2. My hypotenuse is 1 across from the 90-degree angle. So it's going to be negative 1/2, comma, negative radical 3 over 2. As you can tell, this process is getting more familiar. This ordered pair, my hypotenuse is 1, it's always positive. Across from my 60-degree angle, I'm going to think about this as negative radical 3 over 2. And I already determined that value is 1/2. So x comma y is going to be 1/2, comma, negative radical 3 over 2. Let's think about sine, cosine, and tangent now for 60 degrees. Sine is our y value, cosine is our x value, and tangent is y over x. So our y value for our 60 degrees in quadrant 1 is going to be radical 3 over 2. Our cosine of pi over 3 is our x value, which is going to be a half. Our tangent is going to be our sine over our cosine. So again, we're going to have to do a little bit of math with this. But ultimately, this is going to be radical 3 over 2 divided by 1/2. So, radical 3 over 2 times 2 over 1, because I'm going to multiply by the reciprocal of the denominator, and that's going to give me 2 radical 3 all over 2, in which those cancel, and leaves us with radical 3. So our tangent of pi over 3 is going to be radical 3. How can the sine, cosine, and tangent functions be defined using the unit circle? How can real-world problems be solved using trigonometry? Think about these problems tonight, and we'll discuss them in more detail during class tomorrow. After examining the unit circle and trigonometry, try these. Determine sine, cosine, and tangent using your understanding of SOHCAHTOA and the coordinates on the unit circle that correspond to each angle. Then convert each angle in degree measure to radian measure. Map out this chart and we'll discuss this tomorrow. Thanks for joining me in Core Concepts in Algebra 2. See you next time.